Hello friends, I am Chandan. Today's topic is thermodynamic temperature scale. So let's try to understand what is thermodynamic temperature scale. Now consider this is source which have temperature T1 and here there is a sink which has temperature T2, and in between this two temperature limit there is an engine which is produced Q1 W1 amount of work and which absorb the heat from Q1 amount of heat from the source and reject the heat to the Q2 amount of heat to the sink, that means T2. And there is another sink, that is T3, the amount of temperature of the sink, that is the temperature is T3, and in between T2 and T3 there is a engine which absorb the Q2 amount of heat from T2 and reject the Q2 amount of heat, Q3 amount of heat to the T3 and produce W2 amount of work. Okay, so basically this is the engine in series. Now if there is a temperature limit T1 and there is a temperature, that is sink, that is T3, and if this engine, the third engine which is in between this T1 and T3, and basically this absorb the E3 engine absorb the Q3 amount of heat from the T1 and Q3 amount of heat rejected from to the T3 and produce W3 amount of work. So consider E1, E2 and E3 all of are reversible engine. From here you can say that if you want to calculate the efficiency, that is efficiency of 1, that is equal to engine 1 efficiency is 1 minus Q2 by Q1, and and you can say that so 1 minus Q2 by Q1, that is basically function of T1 by T1 and T2, because here there's a this efficiency depends on these two temperature limit, that is T1 and T2. Okay, so here so for engine 2 sorry, for engine 2 this is so Q2 by Q3, this is basically depends on the G dash this is basically function of T3 T2 and T3, and from engine 3 here Q3 by Q1, this is basically function of T3 and T1. Okay, so from here you can see the proof. So from here basically you can prove that is Q1, so Q1 by Q2, that is basically T1 by T2. And if you see that this is also proof that Q2 by Q3, that is equal to T2 by T3, and Q3 by Q1, that is equal to T3 by T1. Only the reversible engine or cycle is there. So basically it's proof that is Q1 by Q2, that is equal to T1 by T2, and Q2 by Q3, that is equal to T2 by T3, and Q3 by Q1, that is basically equal to T3 by T1. Okay, now let's try to understand what is heat engine. Heat engine basically there is a source and there is a temperature sink, and consider that is T1 is greater than T2. Now there is a heat engine, is there that produce some amount of work and that absorb the heat from the Q1 amount of heat and reject Q2 amount of heat to the sink. So if you want to calculate the efficiency of this heat engine, that is equal to 1 minus Q2 by Q1. So this is basically 1 minus heat rejection by heat supplied. So 1 minus Q2 by Q1, and this is this formula is applicable for reversible and irreversible engine. Now if you want to calculate the Carnot cycle efficiency, or you can say that reversible efficiency or maximum efficiency, or if you want to calculate the best or ideal efficiency, that is basically 1 minus heat rejection by heat supplied, that is basically equal to 1 minus Q2 by Q1. So this is basically 1 minus T2 by T1. So this is very very important. If you want to calculate the maximum efficiency, that is equal to this formula. You have to remember this. So if you want to calculate the maximum efficiency, that is equal to 1 minus T2 by T1. So when this is 1 minus T2 by T1, then you can say that this is for reversible heat engine. This is for reversible heat engine. Now, if you focus on the refrigerator, in refrigerator there is two temperature limit, that is T1 and T2, and consider T1 is greater than T2. Now, the reversible the refrigerator is basically absorb the heat from the space, that is Q2 amount of heat which is absorbed from the space, and Q1 amount of heat is redirected to the source, and there is some work done to the system is required to run the refrigerator. Okay, so if you want to calculate the COP, coefficient of performance of this refrigerator, that is basically Q2, that is cooling effect by energy input or work input, that is Q2 by Q1 minus Q2. So this is from here you can say that Q2 by W net, and this is applicable only for reversible and irreversible engine. Now if you want to calculate the reversible COP or Carnot COP or maximum or based on maximum possible COP, then the formula is T2 by T1 minus T2. So this is basically replace T2. So Q2 is replaced to T2 and Q1 is replaced to T1 and Q2 is replaced to T2. So this is basically the maximum COP formula. So this is very very important. So this, if this is there, then you can say that this is for reversible refrigerator. Okay, reversible COP. Now if you want to calculate the heat, if you want to focus on the heat pump, there is a temperature T1 higher temperature and this is a lower temperature, and in between there is a heat pump, and heat pump which is required to run the W amount of work is required to run the heat pump, and this is basically supply the heat to our room and absorb Q2 amount of heat from the outside. So here if you want to calculate the COP, that is basically heating effect by energy input, so Q1 by Q1 minus Q2, so Q1 by W net. So this is applicable for reversible or irreversible both. But if you want to calculate the maximum COP or reversible COP or reverse Carnot COP or maximum COP or ideal or best COP, then the formula is T1 by T1 minus T2. Okay, if the formula T1 by T1 minus T2 is there, then you can say that it is for only reversible heat pump. So this formula is valid only for reversible heat pump to calculate the maximum COP. Okay, so okay, now from here you can conclude that here the actual COP or so here sorry the actual efficiency or the COP, coefficient of performance actual, is always less than the efficiency of maximum or reversible efficiency, or you can say that COP of maximum or reversible. So basically efficiency of actual efficiency is always less than maximum efficiency, and actual COP is always less than the maximum COP, okay, or reverse COP. Okay, so here if the actual efficiency is equal to maximum efficiency, you can say that this is a reversible engine. Okay, now if the actual efficiency is less than maximum efficiency, this is a irreversible engine. And if the actual efficiency is greater than the maximum or reversible efficiency, then it is basically not possible. Okay, so this is my handwritten notes. You can download it from the description. All the PDF links are given on the description. There is a Telegram link. You can join that Telegram link, Mechanical Bengali. Like, share, subscribe my YouTube channel. Okay, thank you everyone.